This morning, someone poured cow's milk into a bowl of cereal and never gave it a second thought. But that ordinary splash depends on a deeply unusual decision. At some point, humans began taking milk made for another animal's baby and consuming it themselves. Now, rewind more than 9,000 years. An early herder watches a calf feed from its mother. The liquid is clearly food, but could it feed a human too? We will never know who tried it first, but we can ask what probably happened when someone did. The first experiments likely came after people began managing cattle, sheep, and goats. Milk offered valuable nutrition without killing the animal. There was just one problem. Many adults could not digest much fresh milk comfortably. So why try it? Did the first drinkers become sick? Did they swallow it fresh? Or accidentally transform it into something easier to eat? And how did this strange experiment eventually alter human DNA? The answer begins not with a glass, but with the animals standing beside the first farming villages. For hunter-gatherers, wild milk was almost impossible to use regularly. Finding a nursing animal was difficult. Getting close enough to milk it was worse. And even if someone succeeded once, the animal would soon disappear. Domestication changed that. As communities began keeping sheep, goats, and cattle, nursing females were suddenly nearby for weeks or months. But collecting their milk still required skill. Herders had to protect pregnant animals, manage births, calm nervous mothers, and leave enough milk for the young. These animals were not modern dairy breeds. They produced much less milk, and only during part of the year. One failed birth or harsh season could reduce the entire supply. Even so, the reward was enormous. Meat could feed a group once. A living female could provide milk repeatedly, while also producing more animals. Milk carried water, fat, protein, and sugar. It turned grass that humans could not digest into food they could use. For a community facing an uncertain harvest, even a little extra nutrition mattered. But reaching the milk was only the first challenge. The next one was surviving what happened after it entered the body.
Imagine one unnamed herder lifting a rough container and taking a cautious drink. This person is a reconstruction, not someone preserved in history. But the reaction is biologically plausible. The milk tastes rich and slightly sweet. At first, nothing happens. Later, there may be bloating, cramps, gas, or diarrhea. Or perhaps the amount is small enough to cause little trouble. The reason is lactose, the main sugar in milk. Human babies normally produce an enzyme called lactase. It breaks lactose into smaller sugars the body can absorb. In many people, lactase production falls after childhood. That was probably true for most early farmers. But this did not mean every adult reacted identically. Symptoms depend on the person, the amount consumed, other foods eaten with it, and the microbes living in the gut. A few sips were not automatically disastrous. Still, drinking a large bowl of fresh milk could be unpleasant, so the first attempt may not have looked like an obvious success. Why then did people keep returning to it? The answer was buried for thousands of years in slaughtered bones, stained pottery, hardened dental plaque, and ancient DNA. The first clue comes from animal bones. When archaeologists study an ancient herd, they examine which animals were killed and when. A community focused only on meat might slaughter animals at the age that produced the greatest return. A dairy herd can leave a different pattern. More females kept alive into adulthood, with some young males killed earlier because fewer were needed for breeding. Bones cannot prove that someone drank milk, but they can reveal that herders were managing animals in a way consistent with milking. The second clue is trapped inside pottery. Fats soak into the tiny spaces within clay vessels. Thousands of years later, chemical differences can help researchers distinguish dairy fat from the fat of an animal carcass. Pottery from northwestern Anatolia contains evidence of dairy processing as early as the 7th millennium BCE. As farming spread, dairy residues appeared in vessels across parts of southeastern and central Europe. At some sites, researchers have even directly dated the milk residue itself.
But a milk-stained pot is not an ancient drinking glass. It may have held fresh milk, but it could also have been used to heat it, ferment it, separate curds, or store another dairy product. The evidence proves that people were using milk. It does not reveal the exact recipe. The third clue comes from human mouths. Dental plaque can harden into calculus and trap proteins for thousands of years. Scientists have identified milk proteins inside the calculus of ancient people. Sometimes, those proteins can even point toward cattle, sheep, or goats. In northeastern Africa, this method has directly connected people to dairy consumption at least 6,000 years ago. It shows that milk was not merely collected or stored. Dairy entered real human mouths. Then comes the fourth clue, and the strangest one. Ancient DNA allows researchers to look for genetic variants connected to lactase persistence, the ability to keep producing lactase into adulthood. Yet many early people who used dairy did not carry these variants at high frequency. In other words, the archaeological evidence says they consumed dairy, while their DNA says most were not genetically prepared to drink large quantities of fresh milk. That apparent contradiction reveals the real breakthrough. Early humans did not wait for their bodies to change. They changed the milk. Fresh milk spoils quickly, especially without refrigeration. But leave milk under the right conditions, and bacteria begin consuming some of its lactose, turning it sour and thick. To an early herder, that change may first have looked like failure. The smell was different, the texture was unfamiliar. Yet some fermented milk remained edible longer and was often easier to digest. Curdling produced an even greater transformation. When curds were separated from watery whey, much of the lactose left with the liquid. Pressing and aging the curds reduced it further, creating a concentrated food that could survive longer than fresh milk. We do not know exactly who invented the first yogurt-like drink or cheese. It may have happened many times. Nor can we prove the popular story that milk first curdled inside a pouch made from an animal's stomach. It is possible, but it remains a hypothesis. What the evidence does show is more important. Early communities could benefit from dairy without first evolving new digestive biology. The first dairy revolution may not have begun when humans learned to tolerate milk. It began when they learned to transform it. So, what happened when ancient humans first drank animal milk? Probably not one dramatic discovery in one village. As herding spread, different communities likely experimented independently. Some people tolerated small amounts, others experienced discomfort, and successful methods were remembered. 5 forces turned those experiments into a food system. First came domestication. Humans could only collect milk regularly after they controlled where animals moved, bred, and gave birth. Second came nutrition. Milk offered recurring calories from an animal that remained alive. During shortages, that could make a herd more valuable than its meat alone. Third came experimentation. People learned when to milk, how much to take, which animals were manageable, and which members of the community could tolerate the result. Fourth came processing. Fermentation, curdling, and separating whey converted a fragile liquid into foods that lasted longer and contained less lactose. Finally came cultural transmission. Children watched adults handle the herd. Families repeated methods that worked. Neighbors exchanged animals and techniques. A useful experiment became a tradition. This is the key. Culture moved faster than evolution. Humans built dairy economies first,
Only later did natural selection make fresh milk easier for many adults in certain populations to digest. But if every mammal produces milk, why did only a small group of animals enter this partnership? Milk being edible was never enough. The animal producing it also had to cooperate. An effective dairy animal had to live near humans, breed under human management, tolerate being handled while nursing, and produce enough milk to repay the work. Living in groups helped. Providing meat, hides, manure, or labor made the animal even more valuable.
Early wild cattle were powerful and dangerous. Only after generations of domestication did their descendants become dependable animals to manage closely. Deer can be tamed in limited settings, but they are difficult to control and milk at large scale. Zebras produce milk, but their behavior resisted the kind of domestication achieved with horses. Predators presented an even simpler problem. Approaching a nursing lion would risk more calories than its milk could ever provide. Sheep, goats, and cattle occupied the rare middle ground. They were social, useful, manageable, and productive enough to reward human effort. Humans did not select dairy animals by comparing the taste of every milk on Earth. They used the animals that history and domestication placed within reach. And once milk became part of daily survival, the relationship began changing humans in return. Dairying created a feedback loop. People managed animals for milk. Processing made dairy more useful. Herding communities grew around that resource. Then, in some populations, genetic changes allowed adults to continue producing lactase. Those changes did not appear once and spread to everyone. Different lactase persistence variants arose in populations with long dairying traditions, including parts of Europe and Africa. The advantage may have been most important during crisis. In ordinary times, a person who poorly digested fresh milk might simply feel uncomfortable. During famine or disease, diarrhea and dehydration could become deadly. Someone able to use fresh milk safely had access to extra fluid and nutrition when other foods failed. Across many generations, that difference could raise the frequency of lactase persistence variants. But genes were only part of the story. Millions of people continued using dairy through fermentation and cheese without becoming genetically lactase persistent. Milk influenced what people ate, how they bred animals, where herders moved, how communities stored food, and even which genes became common. Humans reshaped livestock, and livestock helped reshape humans. Think again of that unnamed herder holding the first cautious mouthful. They could not know that the experiment might outlive their village. Their body may not have been perfectly suited to fresh milk, but human beings had another advantage. They could observe, alter, remember, and teach. They did not need to wait for evolution. They fermented the milk, separated it, preserved it, and passed the knowledge forward. Then, over thousands of years, evolution followed the path culture had opened. So the milk poured into a modern bowl is more than food. It is the surviving result of an ancient negotiation between hunger, animals, invention, and the human body, one that began in clay pots and for some populations ended up written into DNA. And milk was only one dangerous experiment. The next mystery is how ancient humans discovered which unfamiliar foods were safe to eat at all.